variables, what those mean. Anytime, again, you see that little sub O, little subscript with a little 0 right there, that means initial. So in this case, the V sub O, that's the initial velocity, how fast the object is going. The angle will always be given, the theta right there, it'll be the same. And then the Y sub O, that's the initial height. So different examples of that. Our first example deals with hitting a baseball. Well, the baseball gets pitched, and you hit the baseball before it hits the ground. So there's going to be initial height. In this case, I think it's 3. If you're kicking a soccer ball or hitting a golf ball, the initial height could be 0. So there's times when it's 0. If you're throwing a ball, obviously the height would not be 0. You wouldn't put your hand down on the ground and then throw it. I mean, I guess you could throw it from the ground, but you'd be holding the ball and you'd throw it, so there'd be initial height. So that's what the Y sub O is. Notice for the horizontal and cosine go together, x and cosine, the vertical y and sine go together. So that's how you can remember which word goes with which component, x or y. And if you kind of compare this to what you did maybe in Algebra 1 or Algebra 2. In Algebra 2, you'd be given that second equation only, where you would have time and height. So after 5 seconds, how high was the ball? Or when was the ball 10 feet off the ground? And there was a time it was 10 feet off the ground on the way up and on the way down. But with parametric, x and y, those are both distances. X is your horizontal distance and y is your vertical distance, and there's a time. The parameter moves along with that. So, depending on the problem, sometimes you have to use both of those equations in order to find the answer to the question. Alright, so this first example tells you he hits a baseball 3 feet above the ground, the initial speed, which is going to be the initial velocity, and it gives you the angle. So write the parametric equation. So looking at those parametric equations right now, we just fill in what we know. X is going to equal the initial velocity, so 150 cosine of 18 degrees, and then t. So x and t are the two variables in that equation. In the second equation, the y and the t are going to be the two variables. So y equals negative 16t squared, that's part of the equation, that doesn't change, plus 150 sine 18 degrees times t, plus the initial height, which in this case is 3. So now that you have your two equations, we're going to use those equations to answer all the questions. And again, sometimes it's just straightforward, like letters B and C, they are very straightforward. What is the horizontal or the vertical distance at 1.5 seconds? So in your calculator, in degree mode, because we're hitting the cosine button, you would just type in 150 cosine. Now it's going to open the parentheses, so be sure you close it before you multiply by that 1.5. So when you do that, you should get 213.988 feet. And all it says is horizontal distance, so we don't have to specify. If we want to be more specific, we could say feet away. Alright, everything in this unit is degrees. So your test on Thursday, when you get that calculator, we clear it, it defaults to radians, you need to change it to degrees right away. If you get an answer that doesn't make sense, first thing to check, make sure your calculator's in the right mode. Second thing to check, make sure you type sine or cosine correctly, cosine with an x, sine with a y. After that, it would be maybe a parenthesis. After that, you just probably typed in the wrong number or left a digit out. Alright, and then the next question is just what is the vertical distance at 1.5 seconds? So, negative 16 times 1.5 squared plus, what are we at, 150 sine, again, be sure you close that parentheses before you multiply by the 1.5, plus 3. And there's lots of different ways you could do that. You could put it into y equals, go to your table, put it into y equals, do your ask function if you know how to use that, or just plug it into a blank screen. You can store x is 1.5 and type in an x instead of a 1.5. Lots of different ways to do that. And when you do that, you should get 36.529. And again, if you want to be more specific, feet up. So anytime it says how many feet away, that's going to be horizontal. If it says feet up, or in this case vertical, that would mean vertical distance. Feet up is vertical, feet away is going to be horizontal. All right, so those are the basic straightforward questions. This next question, you have to do kind of a combo of the two equations in order to answer it, because it says, will the ball clear a 20-foot wall that is 400 feet away? So we can't just plug in 20. If we plug in 20 for y, then we get a time. It says, will the ball clear? Well, we have no idea. All we know that it took a certain amount of time to get to 20 feet high. But there's going to be a 20 feet high on the way up and on the way down. So you first have to figure out how long did it take you to go to the wall. So if you need to draw a picture, here's Matthew, hits the ball, here's 400, here's the wall that's 20. We want to know, does it clear it or does it not? So the first thing we need to do is figure out how long it took to get to the wall. So the way to find that is 400 equals 150 cosine of 18 degrees t. So we divide by 150 cosine of 18, and you get your t to be about 2.8. Again, either store that answer or keep it available to scroll up and grab it. If you did not get 2.8, what you probably did not do is when you divided right here in your calculator, you need to do 400 divided by 150 cosine. It'll open, close, close. If not, it'll do the 400 divided by 150 and then move that cosine back up to the top. So make sure the whole 150 cosine of 18 is in parentheses. So again, the 2.8, that's how long it took to get to the wall. So now that we know how long it took to get to the wall, we know the t value, we can figure out how high it is at that value. So now in your calculator, you would just do, you can store this or scroll up and grab that number. So negative 16t squared, where t is this number right here, plus 150 sine of 18 times that t number plus 3. And you get 7.178. So, does the ball clear the wall? No, because it's only 7 feet high. After 2.8 seconds, it's only 7 feet high. So the answer would be no. Let's see. Work, ask me now so we can fix it before Thursday, because Thursday's going to be too late. Now, another question that could be kind of with this one. The question could say, will the ball clear a 20-foot wall? If so, by how much? If not, by how much? So in this case would be if not, so no. And by how much did it not clear? Well, it'd be 20 minus 7. And you'd write that answer down. And how would you show work for this problem? Well, what I would expect to see is this number right here somewhere, that 2.8 written somewhere, and that 7 number written somewhere. Writing those numbers down is showing work. Okay? I don't care if you write this whole equation down again or not, but I want to see at least those two numbers. That's what I'm looking for as far as work goes. Did you write those two numbers down? I don't have to see every single little thing you typed in the calculator. But if you're not sure, how do I show work when I put in my calculator? Write down what you typed in your calculator. That will always ensure that you've shown enough work. Okay, but I need to see those particular numbers, and then that supports your answer of no. If all you have is no, you're not going to get any credit. I need to see those two numbers somewhere in order to get credit. Another question, there's one like this on your homework. It says, would someone be able to catch that ball? So if the ball was 7 feet off the ground at the wall, would someone be able to jump up and catch that? Probably. Okay. If that answer had been 30 feet, would it have been able to be caught? No, probably not. Someone probably can't jump 30 feet up in the air. Okay, so just a little bit of common sense when you're answering these questions. All right, and then this next question, E and F go together. So D is over. The wall has gone away. Or fence. Now it's a fence all of a sudden. So we're going to assume there's no fence. We want to know, when will the ball hit the ground? So again, drawing a picture sometimes might help. Here's Matthew. He hit the ball. It's going to land right here. So we want to know when. When means time. So we're looking for T. The ball hit the ground. Well, even though there aren't any numbers, hitting the ground tells us that y is equal to 0. So if something's on the ground, that gives us a vertical height, and vertical is the y. So we know y equals 0. We want to know, what was the time when y equals 0? So in our calculator, we can put y1, 0, and in y2, we would put the equation. Again, be sure you put parentheses, and you could just use the X button instead of, you don't have to go and find alpha t. You can just do the X in the y equals. I think I flip-flop, and when I put them in the calculator, I did y2 is equal to 0 and y1 equals. It doesn't matter. All the y1 and y2 is it's going to graph that one first. It doesn't matter which one's graphed first. So you put them in, and hopefully we know this is a parabola, right? So here is the parabola. It's negative. It's going to face down. We know that's the case. Here's y equals 0. We're looking for that coordinate point. We know that y is 0 right there. We want to know, what is the x, or in this case the t value, how long? So second trace 5, go over to where the cursor is closer to the one on the right, because there's going to be two values. We don't care about the negative one, we only care about the positive one. Enter, enter, enter. And there you get your intersection. So your answer is 2.96 seconds. So that's how long it took. All right, so 2.9 seconds in order for it to hit the ground. Now, F relies on letter E in order to get the answer. So if I had not asked you letter E, you would still have to find letter E before you can find letter F. You have to find how long it takes to hit the ground before you can find how far away it is. Okay, you can't do letter F without letter E. Because if we want to know how far away, now here's Matthew, here's the ball. Now we want to know this x value. What is that x value? So x is what we're looking for. We're looking for x when t is that 2.96. Now it's the whole number, not the stored value. So don't type in 2.96, because most of the time you're going to get that completely wrong. It's going to be more than 1/1000th off, so use that whole number. You're going to type in 150 cosine of 18, and then you're going to use that t value right there. Now what's nice, in our calculator, we just found the intersection. So the calculator, no matter what you have x stored in as your calculator, it just overrode whatever you originally had x stored in your calculator. So whenever you find an intersection or a 0, if you go to a blank screen now and just type in x, it has that number stored. It does that automatically. Whether you know that or not, or want it to do it or not, it's going to do that every single time. Okay, unless you store it as something else. So all we have to do is 150 cosine 18 close parentheses x. And you get your answer right there. So 422.322 feet. if you want to say how feet away, remember the away, that's what tells us we're looking for the x value. If you want to add the feet away, you can, but you can just say feet. All right, the next one, we're actually going to skip the calculator part because if you do this on the calculator, the answer is Ben or Ross. And so you writing the word Ben or the word Ross down doesn't tell me that you know how to do it. So we don't really assess that. If you like doing things in the calculator and you want me to show you how to do that, I will absolutely do that. But what we really are concerned about is the algebraic part. Okay, so algebraically, who won the race? So letter C. So number 2, C. We are not going to do that one graphically unless you want me to show you. All right, so this information up here, it gives you that information and then it gives you the 2 equations. Your homework today, it will give you the equations. It'll describe the situation, but then the equations are given to you. And this y1 and y2, that really has to do with the calculator part. So we don't have to worry about those when we're solving algebraically, because all that means, if they're playing capture the flag, they're going to be directly across from each other. So let's think about, they're on a track, and they're both in lane 3. One's in lane 3 on the north end, and one's on the south end, and they're running towards each other. So they're going in opposite directions towards each other, so that's why this is positive in front of the T, and this one's negative in front of the T, because they're going toward each other. The other example of a question like this would be running the 100-meter dash. If they're both running the 100-meter dash, then they'd be going the same way, so the value in front of the T would be the same, and then this y1 and y2, if we're doing the calculator, they would be different, because right now they're both in lane 3 going towards each other. If they were going the same way, then y1 might be 3 and y2 might be 4, and then they'd be going beside each other. But again, that's just for the calculator so that you can see where they are. So to show algebraically, all you do is put in the horizontal distance. What is the horizontal distance they both ran? Well, since they're 100 feet apart, they're going to get the flag. They both ran 50 feet. So for Ben, we would say 50 equals 10 times t minus 0.1. And for Ross, we would say 50 equals 100 minus 9t. And then show algebraically, this is just your work, so you just solve for t. Whoever has the faster time, in this case the lower one, is going to be the winner. So we divide by 10, we get 5 equals t minus 0.1, so 5.1 equals t. So it took then 5.1 seconds to get to the flag. And we do the same thing over here. Negative 50 divided by negative 9. Then we do 50 divided by 9, and we get what, 5 and 5 ninths. Negative divided by negative is a positive, so that's why I got rid of the negative sign, because obviously it's going to be positive. If you get a time that's negative right here, you've done something wrong. So it took Ben about 5.1 seconds. It took Ross about 5.5, right? 5 ninths. 5/10 would be 5.5. So therefore, we just showed algebraically that Ben won the flag, captured the flag, I guess.